Good afternoon, everyone. Hi. Today we are going to discuss about the chapter waste water story. So before finding out what is wastewater story and what includes in wastewater story, let's see what are we going to discuss today. Sewage system, WWTP, which means wastewater treatment plant, and how to become an active citizen. So let's come back to our actual question. What is wastewater story? Before just remove the word story, remember this wastewater. What is the meaning of wastewater? What is found in wastewater? Wastewater usually means that water which contains impurities or things which are not needed inside the water. So let's find out what will be inside the wastewater. This wastewater can be also called as sewage. So sewage is nothing but so let me erase this place to have some things. So sewage contains of 5 important materials, 5 important impurities. Organic impurities, inorganic impurities, then nutrients, bacteria, and microbes. So inside the sewage, there are 5 impurities: organic, inorganic, nutrients, bacteria, and microbes. So let's find out what are like organic impurities first. In organic impurities, now what does the term organic mean? Organic means the things which come from nature or they are derived from nature. Let's say rice. They are not derived from nature. Plants, they are derived from nature, but we cook it to become rice. So even if they are derived from nature and we cook it, even if they can be decomposed into the soil, they are called as organic impurities. So wastewater also contains organic impurities such as vegetables, let's say human feces, oil, and many other organic impurities. Let's go to inorganic impurities. Now this word in tells us that it is not organic. This is not an organic thing. So inorganic impurities are nitrates, phosphates, and other metals. Nutrients. So we know that food contains nutrients, carbohydrates, proteins. Not those nutrients. There are other nutrients also. They are nitrogen and phosphorus. Bacteria. How does water contain bacteria? Now, simple answer. When we wash our hands because we tell that our hands are full of germs. Germs are nothing but bacteria. So when we wash our hands, we wash with soap, water falls on our hand, the germs get mixed with the soap and the soap carries out with water. So here bacteria also gets into the water. So that's it. Bacteria is also present in water, such as Vibrio cholera, Salmonella typhi. These are the different bacteria and microbes. They are microorganisms which are just do the same work as bacteria and germs. So we know the components of sewage and water. So microbes are protozoans, which cause descending. Protozoans are microorganisms. Protozoans does not only cause dysentery. Protozoans means germs. So the protozoans which cause dysentery means they are different germs which cause different diseases. So protozoans which cause dysentery are comes under microbes. Now sewage system. So So this is the just a small rough diagram of sewage system. Here there are two pipes which before going to the pipes, let's see, these are three houses. So I had less place, so I could only build three houses. So let's think this is a colony of houses. In this we have zoomed in into three houses. So here is an inlet pipe and an outlet pipe. So here both of these pipes take in water. Inlet pipes take in pure water and the outlet pipes throughout the wastewater. So the inlet pipes and the outlet pipes are connected to the house, but they are not connected to each other. They are separately placed so that the pure water does not go and mix with the impure water, and the impure water must not go and mix with the pure water. So they are separately placed and both are connected to the house. And I've shown that here is the impure water. There is a big pipe, a very big pipe here. This very big pipe contains this whole big pipe contains the sewage or the wastewater of the entire city. So this pipe has the what do we say? Can hold on to the sewage water of the entire city. So where do we get the sewage from? No, I already told you houses. Okay, other than houses, hospitals, industries, and schools, schools, and many more places where water is also used. So every place water is used. So sewage comes from every place. So every building, every apartment, every hospital, every industry has two pipes: inlet pipe and the outlet pipe. So the inlet pipe contains pure water, and inlet pipe contain the pure water and the outlet pipes contain the impure water. Impure water goes inside the sewage pipe. So this is the sewage system of just the colony or these three houses. The sewage system of the entire city is very complex. So we have only decided to see three houses. This is the sewage system. So WWTP is the full form of wastewater treatment plant, which can be also called as sewage treatment plant, which means all the wastewater is treated here. In the wastewater treatment plant, even the small impurities or even the water is not wasted. So let's check out how it is. There are three ways. Let's go to the first way. There are three steps in the wastewater treatment. So we are finding out the first one. Physical treatment. So in the physical treatment plant, we are going through the first stage. First step in physical treatment, bar screening. Here there is a gap here. Place our marking here. Here there are small gaps. So and here is the big place which is iron. Iron is here. Bar screens here. Water is allowed to flow at a very great speed. So when water is allowed to flow at a very heavy speed, all the bigger components such as plastic bottles, rags, broken utensils, all stay in water. So when they are allowed to, when the water is allowed to flow at a great speed, here the bigger impurities are stuck here. They are stopped to move. They are stopped to go inside the other step. They are here. The first treatment, in the first step, physical impurities are removed. So water is free from the bigger impurities. So the second step. So the second process is grit and sand removal tank. In this grit and sand removal tank, sand and grit, which is the bigger stones and pebbles, are stopped from moving here, and the speed of the water is being reduced here. So the grit and sand get stuck in between these two holes. These are just the what you say, magnified images that I have drawn is magnified. So here these gaps are not so big; they are smaller. So only water can move inside that and mix substances, and the grit and sand get stuck here. So grit and sand is not allowed to move here, and the water speed has been made slower. So the third step. So this is the third process, which goes inside the sedimentation tank. All the water is kept inside the sedimentation tank. The organic matter settles down. Well, sedimentation means settling down of heavier objects in the settling down of heavier objects in a container is called as sedimentation. So heavier objects here, the organic matter settle down and the oil, which is more less weight, lightweight than the water, uh, makes its surface above the water. So the surface, so the matter settled at the surface is called as sludge, and the oil is called as slurry. So sludge is removed with a scraper and slurry is removed with a skimmer. The sludge moves through here into a biogas tank. Biogas tank. It goes to a biogas tank where all the let's say the sludge is being decomposed or transformed into biogas or produce energy with the help of the anaerobic bacteria inside a tank. So biogas is produced. The water, so the water has been transported into an aeration tank. Inside the aeration tank, the water, the aerators generate oxygen inside the water, where the aerobic bacteria with the aerobic bacteria, because they reproduce and grow with the help of oxygen. Oxygen is being pumped inside or generated inside the aeration tank. The aerobic bacteria is allowed to grow and reproduce for 1 day, and for the next 2 days, these aerobic bacteria go on for having a lunch or a dinner every day, because their food here or their main target is to eat the bacteria such as the microbes, as I already told, the Salmonella typhi and other, the Vibrio cholera. They must eat them down. That is what they work. So they eat all the bacteria and they start settling down at the bottom of the aeration tank. So after they settle down at the aeration tank, this is called activated sludge. So this bacteria is called as activated sludge. They are removed and the water can be now called as clear water or purified water, because it just looks as the water as we use daily. Now the last step. After the biological step, biological treatment, the last step or the last treatment. So that is the chemical treatment. Here, ozone or chlorine is being added inside the water, so that ozone and chlorine are chemicals which destroy the other bacteria which are not being eaten up by aerobic bacteria, because as we release into the other water bodies, they need to be extra pure, so that they do not pollute the water, they reproduce and they destroy the water which is present in the earth. That must not happen. So to recheck or to repurify, we add ozone or chlorine, so all the extra bacteria get killed. So this is a chemical treatment. So this is what we have discussed in the chapter wastewater story.